Everything we're talking about today is about how we enable value at scale. That scalability starts here in the basement. This is where everything comes together. But let's talk about what's special about that basement, why it's differentiating for us, and why we are absolutely different than what everyone else is trying to do at this level. And so Geyer talked about it, right? The data in industry is messy, right? It starts with the problem that it's super diverse. It's not all structured data. There are structured data, but there's a lot of unstructured data in P&IDs and equipment specification sheets, imagery of operator rounds. And then there's a lot of time series data, which is technically structured data, right? It's just a timestamp and a value, but it's trillions of rows of this stuff. And so I can't store, manage, search, aggregate all those diverse data types in the same way. I can't treat time series data the way that I treat files. And that's what causes siloing. And so the siloing is a problem. And then as Geyer mentioned, it's not SQL joinable. Even if I were magically able to bring all that together into one place, I can't actually link it together because the names don't match. The same piece of equipment is called something different in every different data type. And so how do we solve that, right? Well, we tell everybody we solve it with a knowledge graph. But, we were knowledge graph before knowledge graph was cool, right? So knowledge graph is really important because a knowledge graph says, hey, I'm going to find the semantic meaningful relationships between that data, and I'm going to save or persist it. I'm going to know that this pump is related to this file, is related to this work order, even though the data doesn't match. Okay? Everyone else in the world is trying to get the data to match. So you'll hear customers talk about, we have a data harmonization strategy. We have a master data management plan. Those are fancy words for, I'm trying to fix the data. So let's start with that knowledge graph. This is a knowledge graph, right? It's just, entities like a pump or a file or a work order and the metadata associated to it, and we save those relationships and we persist it, okay? Everyone else in the world that talks about knowledge graph, every time you hear someone say knowledge graph or ontology, this is what they're talking about. And this is what they are ending with. This is the finished state for everybody else. This is our starting point. Because in an industrial setting, and at Google, this might have been fine. In Google, with the type of data that you were dealing with, this might have been okay. But in the data that we're dealing with, it's not enough, because it's not enough to know that a pump is related to a P&ID. I actually need to know what's inside that P&ID. I need access to the content. And I need the content of that P&ID to be extracted and added to the relationships of the knowledge graph. The same thing goes for work orders, the same thing goes for 3D, the same thing goes for time series and everything else. It's not enough to know that these things exist. I need to interrogate the content of these things and enrich the knowledge graph with that additional data. So it's great that I can connect it, but now I need access to the content. Well, if I'm going to have access to the content, I need a specialized way that I handle it. We have a highly specialized way that we deal with time series data that's different than the way that we deal with files or records or others. And what does that do? That allows us to have interactive level user performance in accessing that data, super low latency, right? If I say, give me the last year's worth of time series data for these 4 data points, give me the P&ID that the pump is on, all the work orders for the last month, and any alarms or events that were thrown in the last week, all of that appears in less than a second. Nobody can do that. If we ended here, we would be the most advanced industrial knowledge graph in the business. But we don't end here, because on top of this, we add data models. We provide the ability to view that knowledge graph through the lens of something meaningful to the consumer. If I'm in reliability and maintenance, I expect to see industrial data through the lens of an ISO 14224 knowledge data model, right? If I'm an operator, an asset owner, I probably want to see it through the lens of CHIFOS. So instead of creating a different knowledge graph for every different data model, we've got one knowledge graph that can be viewed through different data model lenses. If we ended here, we'd be the most advanced industrial knowledge graph in the world. But on top of this, we wrap all of this in access control and governance, because it's very important that this data can only be seen by the right people at the right time. And if we ended here, We'd be the most advanced industrial knowledge graph in the world, right? But we take that and we wrap it in an open stable API, which is a really boring thing to say, and I hate saying it, but it's actually the most important part of this. By having an open stable API, that's what enables scale. I've got a common way that I can talk to this knowledge graph. So when I build an application for site A or offshore rig A, I can lift and ship that application to another site, to another line, to another rig, and it'll just work. Because it's using the same API to talk to the knowledge graph everywhere you go. So that scalability is unique to us. So what does that look like when you do something at scale? I just talked with a major energy company, and we were talking to their upstream team, and they had 50 offshore assets. And they'd recently done an audit. They for other purposes. They said, hey, how many applications are we maintaining on all those assets? Because they were trying to figure out the cost and whether or not they could cut some of them out. And they determined that there was 140 applications that IT had built for the asset owner, right? And I asked them, I said, well, wow, that's a lot. Are there any of those that you could cut out, are redundant, or that you could eliminate? They said, actually, no. None of them. If we stopped supporting any of these applications, the asset owner would kill us. I said, well, on the bright side of that, you got 140 things that deliver value. It's validated. These are actually valuable things, so that's kind of good. How many of those 140 applications were deployed beyond the initial asset it was built for? 0. That is the scalability problem. So let's talk about AI for just a second. We've all played with it, right? You've done your ChatGPT and your Gemini and all that stuff. What's great about large language models is they require 2 things. They require context and language. It's a language model, right? So context is built into language. So the context is in the content. But industrial data has no context. And it's not language-based, right? If I go look at a bunch of time series data, there's no context in that. And it's not language. It's just a timestamp and a value. But that basement that we built, right? That contextualized knowledge graph is context. That open stable API that wraps that whole thing is language. We've just given context and language to industrial data. So now a large language model can use language, programming language, our open stable API, to access the content in the knowledge graph in a consistent, deterministic way. This is what makes Atlas AI so special, and this is what makes Atlas AI scalable. So when you see our conversations about Atlas AI, it's always grounded in the bottom on the basement, right? Cognite data fusion. That gives context and it gives language to AI. And so Atlas AI is our opportunity to enable AI at scale for industry. So that takes us to the top floor, right? And this is now moving from enabling AI to scaling AI rapidly. Now take that industrial knowledge graph combined with AI that now has context and language and very rapidly scale those insights to our users.